All right, looks like we're live. And if YouTube did its job, it went ahead and sent a tweet out.
Yep, I just got
it. Did you? Okay.
Yep.
And it should have sent it to Google Plus as well. However, it probably did not send anything to my Facebook pages. Maybe it sent one to my personal one. I haven't got it figured out yet as to how to connect the stream to my Facebook pages, but I can post those later. Joe, so how's the screen on your end? Do you see everything okay?
Oh, yes. Looks good.
Okay. Yep. Today's show is going to be about how to save money on your utility bills. Mm-hmm. And we're going to cover everything that will help you through the wintertime as well as summertime. And there is a graph that I would like to show you. So let me get into screen sharing here real quick. And the screen share, oh geez, I'm sorry. The graph here shows what is our most used highest utility usage. And now this is designed for the upper United States or basically anywhere where you get the cold extended winters. Now this is going to be a little different if you're southern half of the United States or any other part of the world where you're primarily warm for the most of the year. So with that being said, this being winter time now, and I know some of our viewers it's summer in Australia, so they're basking in the sun and going to the beach while we're shoveling snow up here in Michigan. So, but anyway, you'll see on the chart here that in this particular part of the world, 29% of your utility bills or utility usages are heating your home. So obviously, if there's some steps you can take to minimize that. The next most used utility or to energy consumption is to cool your house. And then you got heating hot water. You've got other appliances, and we'll say other appliances are like hair dryers and toasters and vacuum cleaners, maybe freezers, refrigerators, things of that sort. And then 12% is lighting, and other is 11%. And so that other 11% could be things like TVs, radios, phantom power. A big one, a big thing that people don't realize is that your phone chargers and all of that is forgot to turn off notifications. Sorry, that might happen periodically. So you're going to get some usage on phantom powers and things of that sort, and we'll get to that later in the show. Backing up to lighting here real quick. This is the easiest thing you can do right off the bat by swapping out incandescent bulbs if you haven't to compact fluorescents or what's becoming a lot more affordable now that these days. Sorry. Wow, that blew my eardrums out. Boy, I'm all sorts of interrupting the program here, aren't I? So back to the heating real quick. Now I'm going to talk about the heating as soon as I shut this off. I got a new phone, so I'm just going to, I think, power it off for now. Sorry about that. All right, so home heating is... home heating, there's lots of different things that we can do to reduce our heating bills, okay? And one is to have your heating system checked out by a professional. Now, that just happens to be my forte. So having your system checked out and making sure that the burners are clean and the blowers are clean and all of that is definitely going to make sure that your appliance is, or your heating, your furnace, boiler, whatever it is going to be operating at its highest efficiency possible. You can upgrade your furnace if you have money as well. A lot of the older furnaces that are 20 and 30 years old, the highest you're going to get out of them when they're brand new is 70%. They have as high as 96.6% efficient now. And those are definitely super high efficient. Cleaning and replacing your filter. Now that's one of the things that you could do that will reduce bills. And if what'll happen if you don't change your air filter, your heat exchanger heats up a lot more, and the more the heat exchanger heats up, the more that heat goes outside. And so by keeping your filter clean, you're getting more of that heat in the house. It says keep the furniture, carpeting, curtains, and from blocking the registers or return air ducts. Okay, so basically they're just saying making sure that all of your air distribution system or distribution system at all, even if it's a boiler and you have a baseboard heat or anything like that, that it's not blocked. And if you have baseboard radiators, make sure those are cleaned and vacuumed. They tend to collect a lot of dust and things like that. So don't overheat your home either. Overworking your furnace is going to tax you out and make your bills go up. So keep your heating, your temperature set in your home to the point to where you're comfortable, or maybe even just a little bit less, because you can always put on a long sleeve shirt or something like that. Now, if you keep your house at 80 degrees and you're running shorts, your bill's going to go up. And then I guess while you're sleeping here, you can go ahead and set back your thermostat a little bit. You can put on an extra blanket, and the last thing would be ceiling fans can definitely help, because heat rises. And then if you put ceiling fans on and have them blowing up so that the air will travel out and down the outside walls, that's a good way to mix up the air in each room and keep you more comfortable, because it's going to take the heat off the ceiling and get it down to the floor where you're at. All right. So as far as heating systems, I mean, that's a pretty quick overview. Joe, what do you have for everybody as far as reducing some bills? What are some tips and tricks that you can put in there?
Well, mentioned about the heating systems. I mean, well, this goes for heating and cooling. Since my forte is going to be electrical, my concentration is going to be on motor loads and heating coils. So if you do have electric heat, that's going to pull a lot of energy that is unneeded, where you could use wood or use a mass stove or a rocket stove or a natural gas of some sort to reduce your bills that way. Electricity wise, your heating coils are going to be your largest or your consumer. And the other part, what you said earlier, was airflow. If your filters are blocked, your motor is going to work harder to push that air. So you're going to put more of a load on your blowers, and hence going to cause more electricity. So you're not only wearing out your motors and your blower systems, but you're also giving the motor a good workout, causing it to have its own load. So as far as the electrical usage, I know we covered a wide variety of with the LEDs and everything else. The more you could do to reduce your bill, your footprint, is the better off you're going to be in the long run. Yeah, it may cost a little more at first to do your overview, or your go from the old system to a new system, let's say, to take your old equipment and throw it out or replace it. That's the biggest upfront cost of any kind of cost saving measure. But over time, you're reducing not only your bills, you're also reducing how much pollution is being created by what you use. So, but yeah, as an electrical aspect, definitely have just the load of the system, the load of the heat. So if you're trying to overheat your house, like you were saying, that's definitely going to be an issue with electric bills, because it's working harder than it needs to be to maintain a house or a heat that's not even plausible with the insulation that you have in your house.
That's lots of good points again with the electrical side of things, because those are things people don't see. You know, and I want to backstep a little bit and say that it is approximately set to where if you are comfortable at, say, 72 degrees, if you can drop your temperature down in your house by 1 degree, that equates to approximately $10 per month. So by taking your thermostat from 72 degrees and lowering it down to 68 degrees, that is, again, it's an estimate, fuel costs or in house size and efficiencies and all that, but roughly about $10 a month. And you had mentioned electric heat, and I failed to mention that, man, resistive loads like space heaters and baseboard heaters and the heat pumps. A lot of heat pumps operate as a single stage, or excuse me, a two-stage. Primary is the heat pump. Secondary is coils. So if you are using some type of heat pump source, whether it's a ground source, geothermal, or you're talking a heat pump with electric strip heat, if that system is not operating at its peak performance, you are just putting yourself in the hole by running those electric coils.
And something else I'm adding, if I can.
Yeah, go ahead. Yeah.
You mentioned the geothermal. That's another great aspect, because you're not only running instead of trying to pull heat from cold air, you're actually pulling a usable heat from the ground source. So it'd be a water-based or a coolant-based glycerin type. And that is much more efficient. I mean, basically what you're running is a fan, a small compressor, and a pump, and you're doing a lot more work. On the other side of what we talked about earlier was the airflow. A new thing that's coming around now is variable frequency drives, which allows you to actually speed and slow according to your load. So, again, if this system was installed, it'd be a very high upfront cost, but in the long run, you save a lot of money, a lot of time, and a lot of energy, because when your system is really needed, it's going to spool up. It's going to have a higher velocity in your fan, and going to push more air. When you don't need it as much, it's going to pull back. So you're not just either on or off. It's in between. So it can vary well.
And you can probably put a little bit more into this, Joe, with you being the electrical guru. But there is available now ECM motors that you can change your furnace, the regular furnace motor that or the electrical motor that comes in your furnace is just an AC motor. It is completely inefficient. But there are so many different manufacturers now that's making ECM motors that you can ask a heating contractor to just swap out that motor. Some people use fans to run all the time, where they are circulating air for air filtration purposes, maybe, or they're doing it for hot and cold spots. If the distribution system wasn't set up right, you're going to have hot and cold spots throughout the home or building, and these ECM motors will definitely save a lot of money. So what do you say about the ECM motors?
Well, they're definitely more high efficient. They have a longer lifespan because they're designed to run at higher speeds, but not use the energy. It's a multi-pole motor. It's much faster as far as RPMs wise, for less, more bang for your buck. So you have to put as much into it to get a lot out of it. Very, very efficient. And like you were saying about the constant airflow, yes, you're running a fan almost 24 hours a day at a low speed, but what you're doing is you're moving air, so you don't get those cold spots. The cold spots are what hit the thermostat. The thermostat is what calls for heat, and so on. So if you keep that warm air, even from body heat in the house, just constantly circulating, it's going to help reduce your bills as well.
And one more thing to add to that is that when you run a fan all the time, well, let me back up and say that if you don't have a humidifier in your house, whether it's like, some type of console style unit when it sits in the living room and you pour water in it, like the old days, or you have a central humidification system connected to your furnace ductwork. If you have one of those, excuse me, that thing can only kick on really when the heating is running. And a lot of times they're installed where they'll only fire up when there's a call for heat, where there should be installed where anytime it's a call for fan or the fan is running. And with these ECM motors, you can definitely make sure that you're getting the humidity in the space that you're looking for. 40% is a pretty good number to start around with, but the colder it gets outside, the lower that humidity level needs to get, because otherwise you will start to condensate on the windows. So Joe, I think ECM motors and these types of motors, and maybe we can talk about different motors and motor efficiencies, and maybe even get into frequency drives in a future video. What do you say about that?
Absolutely. Yeah.
All right.
Definitely a lot to get into more detail.
Yeah, because there's a lot to understand when it comes to those. So I think that'd be a good subject for everybody. Now, hey, if you guys have any suggestions, or you want to definitely hear about that sort of thing, give me a little note down in the comments below. You know what? And I should open up the. I'm going to try to open up our comments window here. I apologize. This is our second go at a live event, so we are working some of the bugs out, and so thanks for sticking with us here. Okay, moving on here, we kind of talked about heating and cooling a little bit. We didn't really talk too much about cooling. I'm going to brush over that real quick, and again, if anybody wants any more information, please by all means leave some questions down in the comments below. We will definitely address those. But what we're going to be looking at for cooling wise is on the big picture, we are fighting the sun when it comes to cooling. So understanding that if we get ourselves in the shade, we're going to be a lot cooler. So there's things you can do, like putting exhaust fans in, sucking the heat out of your attic, putting more insulation in. And you know what, Joe, we didn't even talk about insulation. I guess it goes without saying, insulate your house, right? So if you are going to build a house, position it so you don't have a ton of glazing or glass facing south. If you're in a hot climate, but if you're in a cold climate, having glazing or glass facing south makes sense, because then that sun can come in through those windows. If you need to install some type of shade hood over the windows, you can run tinting, drapes. There's lots of different things. You can get glazing and glass with reflector coatings put right on the glass, and use nature. Plant some trees. Use the leaves to help block the sun off your house on the south side of the house if you can. And again, we're talking about efficiencies. The thermostat. Now, first and foremost, an air conditioner's job is to remove humidity out of the space. It's not cooling. It's not designed to just remove the heat, because if you just remove the heat and keep the humidity in the space, you're going to feel cold and clammy. The humidity level will be too high in that space. So the air conditioner's job is to run extended long periods of time and reduce that humidity. Once that humidity is gone, then cooling is secondary, and it comes right behind it. So that's I guess that's we can get more into relative humidities and comfort zones and things like that in a future video.
Also, like what you're saying too, is air conditioner's job not only to remove the humidity, but it's also you don't create cold, you remove heat.
Yes.
So, and that's what the whole job of the whole system is. And again, we'll talk about that humidity level in a future video and how that works. But essentially, you're taking the heat from inside and moving it to the outside, and that's how you're cooling a house. So you don't, heat always travels to cold, and you just got to get that. You got to take the heat and remove it by absorbing it into a liquid or a coolant and sending it out. Hitting on a few things that you were saying also about the cooling and insulation. Yeah, the attic fans will work. Also having your ability to pull the heat off the house manually, mechanically, take a blow and remove everything out of the attic, which is less heat buildup in your house. Like we said earlier, having a constant fan moving air, which helps with heating and also helps with cooling, because you're taking that cold air or less heated air and putting it back in the house. in addition to trying to reduce humidity for comfort and also cooling the house down. So there's always a lot of ways, and keeping your thermostat at a reasonable level is also a good way to reduce your energy too. Because keeping an ice box for, if you notice at your refrigerator, big thick doors, big thick insulation. I mean, there's a reason for that. It's designed to keep all that cold in constantly. A house is not designed that way. A house has windows and doors and cracks and leaks, and it's not going to keep it down to 65 degrees or whatever in your house in the summertime. Your system's going to work way too hard to do that. 72 is about the agreed level for everybody to maintain their house at.
Yeah, when it comes to comfort, and we're really talking about efficiencies here. So comfort costs money. So keep that in mind, that comfort costs money. The more comfortable you are, the more it's going to cost. I like to tell conscious customers that are conscious about their utility bills or their expenditures, or even the environment for that matter, because it's all relative. If they're conscious about that, they're going to want to know these little tricks. And the best trick I can give somebody is to, if it's 80 degrees outside, 70 degrees is going to be comfortable for you indoors. Or like Joe said, 72. That's about as low as you want to go on air conditioning. If it's 90 degrees outside, you're going to feel really comfortable at 80 degrees indoors, or maybe 78. Yeah. If it's 100 degrees outside, there's no reason you need to keep that thermostat quite at 72 degrees. You could probably be comfortable at about 85, 86 degrees. Because, if you're going in and out of the house a lot. So you wouldn't want to come from 100 degrees into a 68 degree room, and you want to put your coat on. But and real quick, I think we can go back and talk real quick about in the future we can talk more about attic fans and things like that. I think there's a lot more to cover there. We are really bright, just kind of brushing over all of the stuff. We're not getting into any fine details. There's things you can do on your attic that, because attics are designed for convection to take over. Convection is where the air heats up, it rises, and that air that left is replaced with something. Okay, so that's what your attic is. Heat rises and it goes to the top. And if you look at your house, and some of them have ridge vents across the top, others there's vents or gable vents and all of this stuff. It's all designed to do it naturally. But you can induce that draft by means of AC electric or even solar exhaust fans. So that's something that we can get into more detail in a future video.
Yep.
Again, please leave notes or comments below. What was that, Joe?
As out of that, even those Whirlybird attic fans that are naturally driven by heat itself to reduce heat or pull heat off the system.
Yeah, as they start turning, they create a suction or a vacuum, and pretty efficient. Yeah. And then, you know what? I want to go back to air conditioning real quick, and then we're going to move on to water heaters. But you had mentioned how an air conditioner's design is to not produce cooling, but to remove heating. So again, we'll say, and if you get anything out of this little section of the video, remember that it's hot to cold and wet to dry. Always remember, hot to cold and wet to dry, always, never changes. And with that being said, we're talking about basic equipment right here, the residential stuff. But you want to get into large equipment, we're talking about chillers and water towers and cooling towers and in supermarkets, where all of those large amounts of reach-in coolers or freezers, they all run back to this large, huge system. And before they send that heat out of the building, they send it to storage tanks and store it in hot water. So they will recover as much of that heat as they can. So they suck it out of the product that you're buying there down in the grocery store. They're taking that heat and they're storing it in tanks of hot water so that they can redistribute that to other parts of the store that use hot water. So there's lots of uses like that. And again, we can get into more detail, these larger integral systems and things like that.
And that brings up a great point, is that, the heat, the cool, and the electric energy is, you can't destroy energy. It's always, you move it, you can transfer it. So when you have, let's say, lights, you're producing heat. When you have the air conditioning system, you're removing heat from the system, or from the unit, the house, to produce cold, or to leave cold. I guess you're pulling the heat away, so you're leaving cold. But that's an excellent point. The more efficient systems are using the energy in multiple ways to be more efficient in other ways, as in the water heaters. You're taking the heat from the room, you're heating a water, or a liquid, or a some kind of a gas, if you wanted, and using that elsewhere, for various purposes. Some cooling systems, I know that they will get sub freezing temperatures, and they actually need a defrost mechanism, and that also is a stored heat. So energy can be moved around efficiently and used other places. We're always going to have hot water. We're always going to have things going on that are, we use heat. Even in the middle of summer, we want hot showers. That's natural. And like you're saying, having a hot water heater, which goes into our hot water subject.
What a great intro to the water heater section of this video. Hey, so moving on to the water heaters, everybody has a water heater. I'll just real quick, the two most common styles of water heaters are electric and gas. When you're talking about electric, there's really not much to it. It uses a resistive load, an element that pumps 220 volts to it, and it's just a high resistance material that gets hot, heats up the water. I did a previous video, which if I can, I'll try to leave a link below, that basically explains exactly how an electric water heater works. I went through all the thermostats and the wiring and all of that stuff, so check out that video. But when it comes to the gas, you can have what's called atmospheric, and again, this maybe could be another video, the differences in types of appliances and even how they're classed out maybe in the code book. But we're going to talk about atmospheric, which is the old style that vents with a metal pipe. And then you have induced draft or higher efficiency, or sometimes referred to as power shot direct vent water heaters. And these are higher efficiencies, and they have an induced draft motor on top, and they vent with PVC. And the reason they vent with PVC is they draw more heat out of the flue gases and store more of that heat in the water. And so those are the two most common. But what we can do as far as keeping the utility bills low on our hot water heaters is, first off, is a couple of little tricks is, and everybody's different, so I'm going to kind of real briefly go over a bunch of these. One is put your hand under the faucet and run that to the point to where you can handle it without turning any cold on. Okay. Same with your shower. So if you're taking a shower, adjust that hot water heater to the point to where you're not burning yourself, but you don't need any cold water. Because if you turn on all hot and half cold, then that means that your hot water heater is way too hot. The only reason you would need to do that is if you had a very large family and you need to superheat that water in that tank so that everybody has an opportunity to use the heat, use the water that's in the tank. And make sure that you have no drips in any of your systems. And you can insulate your lines, whether they're in the basement or the crawl space or wherever they're at. You can insulate those and keep that heat in the pipe so that it gets to where its destination is. In some are larger homes, and specifically in commercial and industrial settings, there's typically a hot water loop, so that hot water is circulating with a pump all the time, all the way around the entire building, so that at the point of use, when you turn it on, boom, within just a few seconds, you have hot water, rather than it traveling all the way from the hot water heater to wherever the point of use is. In a design aspect, you'll want to make sure that your water heater, the best design is a bathroom and a kitchen back to back, and typical the water heater's in the basement right there. So you are not having your hot water heater and at one end of the house and your kitchen or bathroom at the other end of the house. So as a design aspect, you have to think about energy when you're designing stuff. And I think we can have many videos on design applications that will save energy across the board. One last thing that I can think of, and I'll turn it over to Joe, is depending where your water heater is, we could put a blanket around the water heater. They come with, about that much insulation, about 1.5 inches, 2 inches of insulation, but you can easily buy a blanket and add several layers more of insulation around the tank, and you're just keeping that in the tank. Over to you, Joe.
Well, yeah, exactly. Insulating the tank is a big one because that heat is stored. It's energy, like we just said, and it's trying to escape. So by insulating it naturally, or what the factory made, that's a good way. A blanket would be just an additional insulation level. It takes longer for that heat to escape, so it's going to stay warmer longer. Also, insulating the pipes to and from is also another method to keep a jacket on your hot water. So even though it's traveling through the house, if possible, like an open basement or walk-in basement, you'd have the ability to insulate all your hot water pipes. So when it gets to you, it's hot, which goes back to that loop system you're talking about. A lot of residential places are starting to go to a loop system. This has been around for years, but it's starting to get more back in fashion, where you're pumping water out and it's a point of use. So it's constantly circulating water in an insulated jacket piping. So the water that returns is only a couple degrees less than it was, and it just keeps churning over. But another couple of things you talk about, gas and electric. There is some alternative ones that are less used, but they're definitely more efficient if you want to go extreme on one side or the other. They have, of course, a lot of the new systems have a port for hot water. So as you're cooling your house down in the summertime, it's producing heat because you're getting rid of heat. So some of that heat goes to the ground to be radiated in the ground itself. But some it can be used. Some have auxiliary ports where you actually heat water from that source as well. Solar tubes are another one. If you had a solar water heater on your roof, you could cause the sun itself to do the work, heat the water, and you're constantly circulating that through a tank, keeping your water hot. There's also systems with wood stoves or pellet stoves. If you're actually burning wood and you have a circulating system that's cooled around a water jacket or something around and that's been used for hundreds of years. Back when they used wood stoves for cooking, that's how they heated their water. So it's with the new systems, new technology, it's starting to come back as an alternative method of heat and water.
Hey, Joe, I want to give an example of that exact thing. Has anybody ever watched the Waltons? Pay close attention to their kitchen. They have a wood stove there, and just to the left of that, they have what's called it's not so much a sidearm, but it is a tank reservoir. And I believe, I don't think they've ever really shown it in detail, but the concept of that is that they have water running through the wood stove. So when they're making a fire, it collects some of the heat off of the wood stove and stores it in that tank right there. And to take that, the wood stove, the sidearms, drawing heat off of these sources, taking it to a super far extreme is compost. There is a way to heat water using compost in an off-grid situation. And then these are ideas that you can use and you can implement, again, design ideas. And we can probably get into a lot more of these in detail, but the composting water heater method is basically you have leaves, grass, any type of organic material, manure, whatever the case is, in a big old pile, and you run tubing in there that you just get a lot of surface area, and compost piles can get in excess of 150 degrees at their peak. So with that being said, if you had enough surface area of pipe in there, black poly pipe running through the composting pile, there's free heat right there.
Yeah, that's exactly as a naturally as the system or compost breaks down, it's gonna build its own heat, which is similar to the geothermal method of the earth having its own heat source of the earth. It's actually creating or producing a heat or a cool at a constant temperature. So the compost is the same thing. As it breaks down, you're producing heat in excess to, and instead of just letting it go off the atmosphere, using that for something is, I've heard of farmers using it for using manure for cow manure, doing the same thing. Capturing that heat as it breaks down in a compost situation.
Boy, we got to be careful. We start talking about cow manure and we can get into methane gas and all sorts of stuff, buddy. We got so much we can talk about on the show. It ain't even funny, but moving on so we can come back to some of these subjects. I think I want to cover like cooking. I'm going to talk about some stoves real quick, and then I'm going to let you talk about some dishwashers and things like that. Right. And don't say just have your wife do the dishes, because you're going to get in trouble. Anyway, getting into cooking, there's the old method of cooking was obviously, using your wood stove and cooking while you were heating your home, and that still holds true today. We burn wood, and I use it to cook potatoes sometimes, or throw a pot of beans or stew or something like that on top of the wood stove and cook while we're heating the house. So some of the things that you do when you're cooking, and I'm not a chef or a cook. I don't do it much, but if you're pulling something out of the freezer, you have to unthaw it, right? So it doesn't make sense to pull it out of the freezer, which you've used energy to freeze it, and then you pull it out of the freezer to stick it in the microwave to then use more energy to de-thaw it, or even sticking it in water that you've had to use electricity to pump out of the ground to use to unthaw it. Just a little bit of forethought here will help you to de-thaw things naturally, and just pull it out of the freezer and set it on a plate, or even pull it from the freezer and put it in the refrigerator, come back the next day. So a little bit of forethought. You don't have to use all that energy to de-thaw things. When it comes to boiling water, energy is escaping a pot if you don't have a lid on it. So by putting the pot on there, the water will boil a lot faster, and thus reducing cooking times and a reduction in energy. When you are to talk about cooking with water and boiling, pressure cooking, you can cut cooking time down. If you cook a roast for an hour and a half or 4 hours in a slow cooker, that's a lot of electricity used. But if you pressure cook that same roast or whatever in a pressure cooker, you can do it in 20 minutes. You have dramatically reduced the amount of energy it took to prepare that food. I am a big advocate of pressure cookers. I love it. So then there's a couple of different types of stoves we need to talk about. One is electric. Again, it uses a resistive load to heat, and they are energy hogs. So by all means, save and take these things into consideration when you're cooking to reduce your bills. The other is gas, and then about what I'm about to say also goes into the other gas appliances, water heaters and furnaces and things like that. If you got a yellow flame, you got an inefficient flame. So you want to make sure that you've got a very good quality, nice blue flame there with a little yellow tip on it. You don't want an orange flame. If it's sooting up, you're totally no oxygen. It's burning too bad. You got to get the right mixture there to be burning it efficiently. And one thing that could cause that, especially if you're burning propane, is low pressure. So you want to make sure there's so many different things that factor into this that you're not going to see as a homeowner or a beginning service technician or things like that. So again, leave comments or questions down below. We'll get to them. Now, let's see, what else have we got? Okay, the new technology is using convection. Okay, so convection ovens, which is what restaurants use nowadays, so especially the higher end restaurants, they don't mass produce a bunch of food sitting there ready for you to eat. They prepare it fresh every single. So what you get with a convection oven is two technologies in one. You get the just the pure heat of the space, radiant heat, and you get convection, and it takes that air and moves it around. And it looks like Joe has a little bit to say about that. I'm going to let him elaborate on anything I'm saying here in just a minute. And then, yeah, I guess that's about really all I have to say. You know, if two other things I'm going to say. If you're going to cook something small, a lot of people live in a house all by themselves. There is no reason you need to heat up a big oven to cook one pot pie. Okay, that makes absolutely no sense. If you're a single individual making one small meal, utilize that slow cooker while you're gone for work, or utilize a toaster oven. These will do just fine, but you're heating up such a small space, you're going to save a ton of energy because you're not heating up all this space. And use your microwave. Now, some people think microwaves are bad for you, other people don't, but they are actually very efficient. They can do the same amount of work that a toaster oven can do in just a matter of minutes versus, a matter of, well, I guess a lot more minutes. But anyway, what do you say there, Joe?
Well, yeah, like just going off what you're saying is the convection portion of the ovens is much more efficient than the old style, just radiant heat. We used to heat up a burner or a heating coil electrically to be able to take that heat, and instead of let it sit there, actually move it around through with blowers and fans and actually use that heat. It's very efficient. And in heating a large mass, a lot of the new ovens will have built-in ceramics into the outer coating to store that heat before it's insulated. So even when it gets hot, it stays hot. But like you're saying, if you're a single person with a single meal, I wouldn't fire a big old oven up for just you. In the wintertime, when you're done cooking, leave that door open, let the heat escape into your house and use that energy elsewhere. Some people like to, put water, a saucer of water, something in the oven to add humidity back in the house because it's going to start, evaporating. Like the old style where people put the old wood or water kettles on your wood stoves, to get humidity in the house. Some people do that as well in the wintertime so they don't get dry skin and stuff. So use the energy as efficient as possible. But the important part of what we're just kind of trying to cover here today is just more of, don't just use energy or don't just leave your oven on, or don't use, if you have a very inefficient equipment, try to add something in that's going to be, a little more higher efficiency and higher ratings as far as heat escaping. And moving on from ovens to dishwashers, we talked about is, the purpose of a dishwasher is to wash dishes, obviously. To do that, it's using hot water, and it's using high pressure water, using pumps, using not only a pump to give us that cleaning effect on your dishes, but also to heat that water to a point where oils, fats, and greases start to deteriorate and liquefy. Sometimes there's an option on there for heat dry, or for additional cool on the bottom to energize at the end of your cycle to heat up the water hotter, or just to produce hot so it evaporates that water, which is great. It works wonderful, but the problem is you're burning energy. So sometimes just a little drying rack might be, or let it sit there, open the door and just let it sit there and do its thing is sometimes better than using that extra energy to dry your dishes. Pre-washing your dishes and running smaller cycles, light load, instead of doing all these heavy washes all the time, just kind of clean it off in the sink and then have a cleaner dish going in. So basically all you do is just sanitize it with hot water for a few minutes and then you dry it and pull it out.
That's a good point too, Joe. Just after supper, just rinse them off, get them done, stick them in there. Or I'm a big advocate for not even using a dishwasher. I just take a few more minutes and do them up. The way I look at it is, you're sitting there pre-washing them. I mean, you're milliseconds from being done all washed it, and just rinse it and sanitize it, put it in the strainer, and let it air dry. Yep. But
And that is the most efficient.
Yeah, absolutely. Or just chuck them in the trash and let somebody.
No, don't do that.
So refrigerators and freezers, and then washing your clothes is next. So refrigerators and freezers. There's a couple of different things. There's a lot you can do with your refrigerator and or your freezer. One is don't overload it. It has to have air movement in there. Okay, it has to, again, it's not pumping cold air in there. It's removing heat, and the only way it can remove heat is having air blowing across it. Cold air will fall across it. It'll absorb the heat out of the product, and it has to make it back to the back of the freezer. There's a lot of service calls I've been on where they say my freezer's not working, and I open it up, and the first thing I see is it's just chucked full. But if you look at an empty freezer, there's little vent holes everywhere, and you have to keep them open, or the air is not going to flow through there. So that's one thing. Another thing is, so that's the inside, the condenser or the evaporator part of it. The condenser side of things is where it has to remove the heat. It's sucking in the air. You know, if you got maybe cats or dogs or dust in general, it's sucking air in there, and those coils get plugged up. So you pull your refrigerator out, take the back off, clean it all out. By all means, de-energize it before you do any of these sorts of things. But by keeping the coils clean, the system can breathe. If the system can breathe, it'll be more efficient. Another thing as far as refrigerators and freezers, don't put hot product in the freezer or refrigerator. Let it naturally cool off before you put it in there. You have realistically about 4 hours before food will start to get contaminated before you need to start to cool it off. So a good rule of thumb is about 2 hours. If it comes from 180 degrees, which is just, or 200 degrees, just come out of the oven and you eat it, and it gets down to, you got 2 hours, and it has to get down to a certain level. And I don't have that information right off the top of my head, but basically there is a time frame that's spelled out with the health department that lets you know exactly what that is. But if you keep a rule of thumb, it makes sure that you have it in the refrigerator by the end of that 2 hours, you're totally good. But and that gives it plenty enough time to cool off. So definitely no hot product in your refrigerator. You're just wasting energy there. When it comes to your freezer, make sure the freezer's full. Don't try to cool off a whole ton of area when there's no product in there, because a full freezer is kind of like a flywheel, meaning that if and when the unit shuts off, all of that product will hold that cold for a longer period of time. And that's a much more efficient way to operate either the freezer or the refrigerator. So keeping them clean and keeping them full and keeping all the vents clear so that there's air movement front and back, side to side. Definitely want plenty of air movement. A little bit of pre-planning on the refrigerator and how you put the product in there. Some people have double doors. We have double door refrigerator with the freezer in the bottom. Know where your milk is. Know where your cheese is. Think about what you're going to grab before you open the freezer or refrigerator. Don't just open it and stand there and look at it, because you're losing all of your air that you've just worked so hard to cool down. So just think about what you're going to get before you get it in there. And if you're going to make supper and I need this and this and this and this and this, open it up, pull all those items out, put them on the counter, shut the door. And that's just another way to save a little bit of money with a little bit of forethought. One other thing is to check the gasket. Excuse me. All the way around the doors, and make sure that that little gasket is actually sealing. In some cases, especially older refrigerators, where that gasket has been kind of gets older and a little more rigid, there's a magnet in there, and it's like an accordion style thing. Okay, so here's the refrigerator face, and here's the magnet of the door. When you shut, it doesn't really shut all the way, but the magnet sucks that to seal, and then there's an accordion seal behind that. So if that doesn't seal, you get air leakage, which then you'll get condensation building up in your refrigerator. But what you can do there is open the door, take a blow dryer, and heat up that gasket. kind of stretch it out a little bit and get it nice and warm. Don't melt it, just heat it up, and then close the door. What'll happen is that gasket will be soft enough and pliable enough that the magnet can then stick to the refrigerator door and let it cool down. And now it has a new memory. And that memory will be to, have up against there to seal. So that's another little quick tip. Excuse me. Temperatures of your refrigerators and your freezers. Set the refrigerator thermometer somewhere between 38 and 42 degrees. Now, 32 to 45 is acceptable, but you don't want to leave it right at the 45-degree mark because anything over that, bacteria can grow, so you want to subcool that a little bit. So 42 degrees as the high point and 38 degrees as the low point is a very good temperature for your freezer or your refrigerator. 5 degrees to 0 degrees is a good temperature for your refrigerator or freezer in the house. And if you have a deep freeze, that one for longer term storage should be about 10 degrees or 10 degrees below 0. So that's it really on the heating or the refrigerators and freezers. And we haven't talked about super old equipment and efficiencies, but obviously it goes without saying, older technology uses a lot more electricity than the newer technology. However, sometimes you wonder, the older technology seems to be more durable, seems to last longer than the new stuff. So that's a give or take. And what do you got to say about any of that, Joe?
Like you definitely just saying is that, a refrigerator is designed to do one thing, it's to cool or freeze. So, what you're doing is you're doing the opposite than a convection oven was doing. We talked a few minutes ago, you're moving energy around. Well, before we're talking about, moving around heat to heat a food. Well, now we're actually removing heat to cool your food or cool your product. But in doing so, it has to say, to move that air around. It has to have airflow, like you're saying. The products, the gas has to be sealed. If you don't, you'll mess your airflow up. The products that go in there have to be, a good temperature. So, everything you're hitting on is great points. That the thing to keep in mind is that it's an energy. If you add hot energy into it, you're having the system work harder and run longer, which burns more energy. If your coils in the back are dirty and it can't dissipate that heat, then that's more energy because it has to work harder to get that heat out. It can't get down to that temperature. If your gaskets are broken or not sealing, like you're just saying, you have the potential of losing heat, which causes your system to run longer, which means your compressor's running longer, you're burning more energy. So small things like that, they're very additive. Your coils being dirty, you can't get rid of that heat, like we're just saying. So if they're covered with dust, they're basically insulated, and there's no way for that heat to go anyplace. And then your compressor's working its little tail off to try to get the temperature down to a usable level. So that's just things to keep in mind. That everything we talk about today is energy moving, energy consumption. So in order for us to cool something down or make something that is more efficient in the long term, you have to think about the small parts that make these things work. So I think in the future we're going to be producing videos that's going to be more in depth about each section. So possibly how to clean the coils on a refrigerator, or how to maintain an oven, or how to clean out your water heater. There's so many subjects we can dive into, and I know these live events are going to be more of a overview to kind of help people understand what we're about. But in the long term, I know our goal is to try to produce these things to people, a regular everyday person, not engineers, to sit there and understand how to reduce energy, how to be more efficient, how to reduce their bills. Because I work very hard for my money, and I work a long time, many hours and I don't want to give it to anybody else. I don't want to give it to the power company, or I don't want to give it to the utility companies or gas company or whatever. I want to keep what I have. So, and it's part of life. You have to pay your bills, you have to pay something, but if you can reduce it down to a point where it's not as dramatic, I think you're in the right track.
Yes, absolutely. Keep as much in your own pocket as you can. Every dollar you don't pay the man, you're getting to keep put food on the table, or buy a little trinket, or upgrade your phone, or whatever the case may be. So definitely efficiency on everything, on a lot of aspects. We will in future get into solar. A lot of people in my channel know that I produce electricity with solar and wind technology. And that is definitely something that is achievable and affordable if you kind of follow our steps and what we're going to bring to you, for sure. There is ways to do these things yourself, or you can hire other people to do it. So this channel is about teaching, like Joe said, teaching you and showing you how to do it so you can do it for yourself. And you know what, Joe? I want to ultimately put together something to help people that aren't, there's mechanically inclined people and there's not mechanically inclined people. Some people can do things and other people have a hard time wrapping their head around it. And I would like to try to put together something that would help people understand these things so they're not afraid to do them themselves, maybe teach them some mechanical aptitude and things like that. I know there's a lot of people just in the neighborhood that say, hey, guy, can you do this? Or my neighbor didn't have a working oven for such an extended period of time, and I went over there and got it running in just a few minutes. It wasn't anything real dramatic, but they didn't know, so they didn't have an oven and couldn't afford to fix it. So there's lots of things that we can bring into the show, because and again, I want to encourage people to please leave comments, because we have a large variety of people coming here. I have homeowners asking specific questions. I have technicians that don't know what questions to ask because they don't have enough knowledge in their head yet. And I've got seasoned people that just watch to learn tips and tricks. So there is such a wide gamut of people here. The only way I know how to channel the information is for you guys to leave comments. So definitely do that, and we can bring more of that to you. Let's talk about washing our clothes, Joe, because that brings a lot. That's a lot of energy there. Where can we save some money washing our clothes?
Well, definitely. So, yeah, if you're just for the washing machines and the heaters or the clothes dryers, that's a lot of energy. I mean, you're using a lot. You're using, of course, water consumption. So if you're on a well system, you're going to be pumping water, or or you're just using water in general. But as far as energy goes, electrical wise, heat wise, like we're talking about, there is so many ways to reduce your energy, like running cold loads. They have a lot more detergents now that are designed and made to foam and to work better with cold water versus the traditional scalding hot water, where you would have the soap or the detergent itself actually break itself down in the heat and the hot water, and to start sudsing and clean your clothes. You're taking a lot of energy to make that. So I just think that the newer systems are very, very efficient at what they do. They're better at running larger loads with less water. They have variable frequency drives on new ones, like the small ones, like soft starts. So they don't have to go, they're not just like full on. They actually will speed up to a certain speed and then slow down. Spin cycles are a lot more efficient, so you get more water out. So your dryer has to work not as hard.
And Joe, don't them washers use that ECM motor technology, like we were talking about in the furnaces? I mean, kind of like, I think some of those are like DC motors, aren't they?
Yes, some of them have a DC motor in there that are very efficient. Some are also AC, depends on the manufacturer. The AC ones are actually slightly more efficient because of their if they're properly paired with a drive. If they have a drive or control system to control speed and frequency, much more efficient. DCs are more wear and tear on the motor itself, but their DCs are notoriously better for a low end torque, and the ACs are more for higher speed or more controllable speed levels. One problem with DC that I've found in my field is, DC has brushes, unless you have a specific or a specialized motor that would, so a little more maintenance involved in the DC. But the AC stuff is going to be very efficient, very, very easy to maintain, because there's not really much you can do to it. Once it breaks, it's one of those throwaway things. But yeah, definitely the new technologies, the motor systems, drives, the technology, the soft starts built into the dryers and the washing machines are very efficient these days.
Oh, that's and about the only way you can do that is to upgrade your washing machine. I would suppose. Our personal washing machine is not brand new. It's a little older, but does the trick. We tend to just wash our clothes as needed. And I the only thing that I know that we do to make sure that we don't use too much water is, if we're doing a small load, make sure you set that selector switch to small load, and make sure you don't overload the washer so that you're getting the maximum amount of cleaning power out of the washing machine. And I wash your clothes in cold water as much as possible. Saves on your clothes. You don't have to heat up that water. And if you're not overloading your washing machine, then that cold water is going to be fine to wash your clothes with. Some people like to wash their clothes in hot water, but it breaks down the material. It sucks the dyes out of your clothes and costs you more to wash your clothes. And then I guess we'll get into some dryers. But before we do that, I'm going to say I'm a big advocate for hanging them outside. When weather permits, obviously. But besides that, you got any thoughts on dryers and things of that sort, Joe?
Well, one thing to save on dryers itself is going to be, like we talked about a minute ago, is if the washer itself is spitting the water out more efficiently, I guess. It's the clothes going to the dryer have less moisture on them, so it's not working as hard. That's one way to do it. Hanging up is definitely another aspect that is probably the most efficient of anything. Some people don't like that. Some people don't like their clothes sitting outside. I don't like that smell of the outside. I like it personally, but some people just don't. And sometimes a dryer is the only way you can do it. You can hang your clothes inside. I've heard of people actually having retractable clotheslines in the house that they can pull out and hang their clothes up. But if you don't have space for that, or just it's not something you wanted to get into, a dryer is obviously the best way to go. And just the clothes going in there being drier is going to help. Make sure your vents are clean. All your screens are very clean, so that motor and the blower doesn't work as hard. You're still producing either electrical heat or a gas heat to produce that, and I'll let you elaborate on that in a second. But the loads itself are tremendous on an electric coal system. So when that coal heats up or energizes, it's going to be a lot of energy right away. And the newer technologies, again, I hate sound like a salesperson where you're trying to sell new equipment, but the advances in technology that are out there are just amazing, as they can actually control the level of how much heat. A lot of the new dryers have sensors in them now. They actually have a sensing technology on the drum itself that senses moisture. So it's not going to run for an hour and a half or an hour or 45 minutes. It's going to run until your clothes are dry. That's going to stop. But on the low end, for those of us who can't afford all brand new equipment, is going to be, your smarter methods. Make sure you're completely spinning your clothes out. Smaller loads. Sometimes a small load you can dry quicker. Another thing old wives tell is you can throw dry towels in with your wet clothes, and that's to help absorb some of that. And of course, now you have a semi-wet towel, but hopefully they'll dry together.
I do it all the time because you got that one thing you got to get clean so you can get out the door and throw a dry towel in there. Gives you a lot more surface area for the air to travel through. So that, again, that wet to dry. Remember, we talked about wet to dry before, and if you got a dry towel and a wet pair of pants, you'll basically equal them out because all that moisture will transfer over, and then you got all that extra surface area. Yeah, a smaller load will spin much better, much faster than a super heavy load that's especially unbalanced. And Joe, we burn wood in our house for the winter, and so there's a lot of things that we will put on our hang up to air dry. So that helps humidity wise and cuts our utility costs down because we can't hang the clothes out in the wintertime. They'll just freeze. So you can't not say that you can't though. You can hang your clothes outside in the wintertime. It just takes a little bit longer to dry. You know, and the sun comes out and you got a little breeze there. The sun, especially darker colors, will absorb the heat and they will dry. It just takes a little bit longer. Okay, what's our next thing we're going to talk about here? I guess we're into lighting, and I'm going to let you start out with the lighting there, Joe.
Yeah, well, so lighting is going to it's going to have its own little issues. Lighting loads, being inductive loads, the old school, incandescent lights, you're going to have a lot more resistance on the lamp because that's the nature of it. It's an inductive material. So in order to produce light, it's actually creating heat, and the heat is produced as inefficient as one. So incandescent lights are just very inefficient in the first place. And that's what causes our electrical problems. So people are going to fluorescent as CFLs, and some people have issue with that over, the waste of a CFL or all the landfill issues. But as far as energy wise, using it in a house, CFLs are pretty efficient. I mean, you'll sit there and you put energy into the light. It will glow with less energy in, more light out, and you get more bang for your buck. The new technology LEDs though, now that's a whole new ball field. We can have a whole video on LEDs and semiconductors and all that good stuff and how they actually work. Very efficient. And now that the costs are actually going down and becoming more efficient to run, more efficient to maintain, and the lifespan is amazing on these things. So I highly recommend LEDs as they come down.
Let me go back just real quick so that people understand. There's probably some viewers that will see this that don't quite understand the difference between incandescent CFLs, which you had said, and LED. So the acronym CFL is a compact fluorescent lamp, right? Is that correct? Lamp?
Yes, that's correct.
Okay. And an LED is a light emitting diode. Okay. So, and then incandescent is the inductive load he was telling you, but that's the one where you touch the bulb, you burn your skin. That's the one. That's the old school stuff. If you still got those, you better get rid of them because you might as well see CFLs or compact fluorescent bulbs, the curly coil ones. Those are very, very affordable these days. LEDs are coming down in price so dramatically that I'm going to say that I probably have 98% of my lights in my house, maybe 95% are actually LED of some sort or another. However, I'm not going to throw away money and just wait till I'm not going to replace a CFL. Currently, the one right above my head that's lighting my face is a CFL. And you can get them at different color temperatures, and this happens to be looks to be maybe a 4,500 Kelvin or something like that. I'd guess. Upgrade your lights. Now remember, 12% of your energy usage is actually the lighting factor. So if you can replace a lot of that. Joe, correct me if I'm wrong. I believe a 60-watt bulb, which is everybody can relate to a 100-watt bulb and a 60-watt bulb, at least the older generation. The younger generation, they probably grew up on CFL, so they automatically think 23 watts or whatever. But is a 100-watt bulb, 100 incandescent, is equivalent to about a 23-watt CFL, correct?
That sounds about right. Yeah, that's okay. You're only building, in wattage. That's a whole other video as well. Yes. But wattage is a series of measuring energy or power. So yes, by using 100 watts of power, you're using 100 units of energy, and that energy is allowed to be turned into a light. So yes, the new CFLs are, rough about 20 something. I'd look at my notes. But yeah, about 20 something watts compared to with 100 watts of output. So what a 100 watt incandescent load or inductive load would have put on 10 years ago, CFL is now, which a compact fluorescent is much more efficient with 20 watts. So less power is going into it, meaning it's you're getting more light for less energy. Now the LEDs, you can get those down as low as 5 or 6 watts and put out 60 or 100 watts of power of light. And the only ways they use that conversion is this, a 60 watt is equivalent to 100 watt is because that's what people are used to, like you were saying. So it's not, you don't have, one or the other. It's you are burning 23 watts or you're burning 12 watts. That's what you're actually using as far as energy wise. What's the equivalent of why they do that is because people are used to that light level. They're used to a certain brightness. So if they say, oh, this is 100 watt light, well, they know how bright they can imagine that in their head. And that's why they use that comparison in the stores. But it has nothing to do with the 100 watts anymore. It's all energy in lumens. Lumens is a measure of light. Wattage is a measure of power. And it's there's when you get the lights and it's a whole technology behind that they were just we can definitely get in detail with that stuff.
Great. Sounds like more videos we can do. I'm liking the discussion we're having just on energy. It's opening doors all over the place. Ultimately, I believe that lighting will be referred to as lumens and Kelvin, or maybe they'll have some sort of scale that in the future that they can refer to, but until they kind of narrow it down to just LED technology, ultimately the incandescent and the CFLs will be out of the picture. And everything will be LED. Excuse me. So there's things that we can do besides just changing out all of our bulbs. And one is I want everybody to take a test and be conscious when you're walking around your house. I'm going to bet that most people have a habit of walking into a room and immediately reaching to the right and flip the light switch on. If I think our brains are programmed to walk through and just flip the light on. I notice even sometimes I do that, and I'm trying to be conscious about it as much as possible. But then I think after I flip the light on, I look around and I can see what's going on in here. I don't need to flip the light on. So try that little test at home and see how you see if you go into a room and flip it on, even if there's light in the room already. Starting with the energy usage and reprogramming how we think about things is definitely going to help. So some of the things that we can do to minimize lighting usage is to put in sensors. There's timer sensors that you can put right in place of where the switch used to be. So when you walk into the room, it notices that you're there, and then it'll turn the lights on. It'll start counting down, and you can have high-end ones that'll count 5 minutes, 10 minutes, up to an hour. There is such a wide gamut of different types of controls that you can put on a light. There's even sound. Some in commercial settings they use occupancy sensors where they are looking for movement and they're listening for sound, and within the two combinations those will turn the lights on and off as well. And again, like Joe's he'll probably tell us the same thing. There's so many different things that, as far as just controls on top of the different types of lights that you can use and do that. But we're just talking about some simple things that we can do to minimize our own consumption of energy. And so let's go back to using the sun. The sun is there for us to use. So open the windows. Don't block them off. If you can use natural light, you're that much further ahead. And painting your house, interior colors, the interior of your house, the lighter it is, the less light you're going to need, because it'll reflect off of the background. If you have dark, brown walls or maroon or whatever, and it's going to take a lot more light to heat that area up, because all that light is going to be absorbed into the colors of your walls and your furniture and things of that sort. Joe, I got dry mouth. Go ahead for a second.
Yeah, so you talk about the control systems for lighting. Like you said, there's a whole bunch of stuff we can talk about on that side. But yeah, definitely the motion sensors is a big energy saver, because when you leave the room, you might forget to turn your light off. And this way here, the control system or the actual electronics actually does it for you. And the sonic sensors, those are coming big in industrial settings, like markets, that kind of stuff. But yeah, there's so many different ways to do it. There's also new technology. It's an older technology, I'll put it that way. It's older technology that's coming back around, and they're using the control voltage, meaning that you're running low voltage your light switch and letting the light switch do the work. Or now in more modern applications, you're actually using automated house systems. So using turn the lights on with the app on your phone or whatever, and that's because the controller, the computer actually has control of these light functions. So you're not actually sending energy through your light switch and sending it back to the light. And just to quickly get into what a circuit would be. You have an energy source, a power source, and a switch. A switch is like a drawbridge. So once you open that drawbridge, no flow. When you close the drawbridge, you allow that flow or traffic through the switch, which sends that energy onto a light bulb, and so on. The new technology is more the computers do that for you. It's closing that gate for you. So it's more efficient point to point, and it controls when the lights are on and off, and when you walk into a room, when you leave a room, all that good stuff.
When you say point to point, Joe, you mean there's actually less resistive load that the electricity or electrons have to travel through to get from the source to the load, correct?
Yeah, that's correct. So the power source, the breaker from your panel box, is controlled or connected directly to a controller. The controller has internal relays, which are electromagnetic contacts, which allows that switching mechanism to happen remotely inside a box or a panel, and that would send power directly to a light. And so there's a lot less load, a lot less inductive resistance, like you were saying, to the whole system. So it's able to, not only be automated, to be more controllable, to be safer, because you're not putting 120 volts in your walls anymore. It's more you're giving the computer a signal to do something. The computer's making the decision to close or open. Some of these newer systems that you can actually program them, where during the daytime they will actually open your windows or open your blinds for you, and will not allow a light to come on. So if you walk into a room and push a light switch, it's going to see that it's bright outside, and it's going to open the windows for you to let light in, versus turn the light bulb on, because it's deciding that there's plenty of light outside to light that up. And the computer is doing the work for you. It's kind of overriding, like you said, the personal programming that we've been doing for years of walking a room and turn the lights on. It's making that decision for you. It's like, nope, it's too light outside. I'm going to go ahead and open the windows, the blinds at least.
What's funny about the way you started that was you said there's an old technology that they're starting to use more. It's been around a while, and first thing that popped in my head was like candles and lanterns and things of that sort. And then you got into something. It's an older technology, meaning the control voltage, but taking that and shooting way beyond my candles and lantern thing into smart houses and things of that sort. That was kind of funny. There's something happened inside my head when you were talking. So, yeah, that's a man. That's not one video. That's like 1,800 videos is to get into something like that. But lots of good information there. And there's probably not much more on lighting we can talk about, but there is one last subject that we really should cover. I brushed over it real quick at the very beginning of the video. I talked about phantom power, and phantom power is just that. It's power that's being consumed and you don't even realize it. So some of the things that are phantom power is the little LED light that's on your TV, the loss in that transformer inside of any piece of equipment that you have plugged in. Most items use actually DC voltage. Computers and TVs and stereos and all of these things, they take the AC voltage out of the wall and they transform it into a lower usable voltage inside the piece of equipment. Those lower voltages are operating processors and LED lights, and the transformer itself has inefficiencies in it, which cause energy loss. So even though your TV is off, it's actually still drawing juice. And even though your cable box is off, it's still drawing juice. Your computer, same thing. All of these devices, your anything that's electronic, and the control on your stove and your phones. When you plug your phone in, you typically plug cord into that black thing. You plug that black thing in the wall. Well, even though you unplug that from the phone, that black thing's still drawing juice out of the wall. And so one way that you can minimize this is by using power strips. If you have a charging station set up at your house with, where you put all your phones, your devices, things of that sort, you can flip that switch off and kill the power to all of these devices. Same thing around your TV, your entertainment center, or all of this stuff. Plug everything into a power strip or a surge protector, and then turn them off when you're not using them. That's just a couple quick tips. Joe, what do you say?
Yeah, it's a good point. I was looking at the comments. I saw Jamie asked a question about the power supply when leaving phones plugged in, which leads into your phantom power thing. Now, phantom power can be a couple of different things. One is power supplies, which are very inefficient. If you notice your laptop or your PC, when you walk around there, feel around the case of it, a lot of heat, very hot. Some of that's coming from the processor, which is just what it does. It's making mains and mains of little closures inside their little switches to make information. That's the processor itself. So it's going to build heat. But the majority of your heat is coming from your power supply, which is a huge loss of energy. Taking a higher voltage, 120 volts, dropping it down to a low voltage of 5 volts or usable electronic, 2.5 volts or 24 volts or whatever your system uses. And that stuff is still active. It's still live in the system. So in order to have a efficient system, like you said, is to cut all that stuff off. Leaving a PC running while you're at work, not a good idea. You're burning energy. Leaving your power supply, your laptop plugged in, even though the computer's not plugged in, it's still burning energy. Like you said, your TVs, it's minute. I mean, the stuff you're using is way lower than you would ever use. It's not enough that one item to make your bill jump on your electric bill. But when you have hundreds of items all doing the same thing, you're going to see a little bit of a difference. And you can tell when the power goes out in the house and you see how quiet your house gets, all the fans shut off, all the lights come off, all the buzzing goes off from the TVs, and you can really start seeing what all the energy is being burnt. And it's a neat little it's a neat concept, that the fact that you can actually take a voltage off the wall and make it usable for many different aspects. Your phone, 5 volts. Some systems 24 volts, like your alarm system, your house, or a lot of computers use 5-volt systems. I mean, but these all have to be transformed, which is again another whole video, from a higher voltage to a lower voltage in order to do this. And a lot of that energy is being lost in heat. So it's definitely out there. Something else when you mentioned phantom power, my background being in audio and lighting systems as well as control systems. Phantom power is used for many electronics for their backup power. So cameras, microphones, audio systems, headphones, a lot of them have internal processors on board, which use phantom power, which is basically a small power source. And all that stuff, it just all burns energy that's unneeded if it's not being used.
I want to bring a little point to forward here that maybe a lot of people aren't aware of, and it's all about what you're exposed to and what you think about. But if you think about back in the 1950s, we didn't have any electronics at all. I mean, there was your TV and the radio and a vacuum cleaner and maybe your electric stove or your toaster or something like that. And that was about it. So you had incandescent bulbs back then, but as air conditioning started to become more popular and more affordable, when it first came out, it was a rich man's appliance. Refrigerators were rich man appliances. But think about today. Everybody has a big screen TV, and you might think, geez, that's a new piece of equipment, and that, it's probably pretty efficient. Well, to be quite frank, if you ever walked up to a big screen TV without a shirt on or a short sleeve shirt, you feel the radiant heat coming off of that what am I trying to say? Off of the face of that. And those, I have a 47-inch TV, draws 300 watts of power. And you add that up with all of the other things that we use, there's actually, I believe it's somewhere in the neighborhood of 300 to 400% increase in a household's consumption of electricity now versus, we'll say even probably up to the 70s versus today. So what do you think about that, Joe?
Yeah, I think the just the difference in technologies has brought the energy usage down. So stuff like older equipment, like I said, old TVs and older appliances, older stuff. The electronics is very, it was good for the time, but it's definitely uses a lot more energy just sitting there maintaining than it does than anything new. All the new stuff is designed just by laws being in place that cause us to go into low power mode. But that still doesn't eliminate the power of the power supply or the transformer still being powered. That always maintains because you got to have that control system to tell the other systems to go to low power. So that constant draw is still there. But yeah, definitely it's more efficient than the old stuff used to be.
So when we talk about energy, Joe, I think we're pretty much concluded all of our, tips and tricks of, things you can do to reduce energy. And let me have a little call to action here. If there's some idea or thought that you guys have, please leave it in the comments below. Go ahead and go down there and check them out. And there's things that we didn't mention, like, making sure your thresholds are sealed, the bottom of the doors, so you don't get air loss and leakage and things of that sort. So there's tons of other things that we didn't cover, but you just possibly can't cover everything there is. But kind of a prelude into learning how to reprogram your thinking and your power consumption, because ultimately solar power can power your home 100%. And if you can learn to reduce your consumption, that's going to help in the long run as far as how to implement some solar or wind technology into your own home, which would require a lot less wattage. If you continue to run everything the way you do on a day-to-day basis and you're running, 2,000 kilowatts a month, well, then you have to purchase 2,000 kilowatts a month worth of power to cover that. But if you can reprogram how you use the energy, and then you can easily achieve a solar system, and we'll teach you how to do those things in upcoming videos and things of that sort.
I see in the comments, John was asking about your solar system. You still using your solar panels?
Absolutely. And I'm glad you brought that up. I forgot to ask you. I set up the chat on one of those sessions you were talking about, and I see the chat window, but I'm not getting anything coming through it. So, well, that's one of those technical difficulty things. Yeah, I do still have my solar set up. When I moved from Virginia back up here to Michigan, I installed the solar system on the shed. I did a video on reinstalling that. I think it was about a 45-minute video. I went through the whole system. I mounted them up on the shed, roof. It was a perfect pitch, facing due south, and I also mounted a wind turbine on top of the shed. So it's not the best perfect location for it, but I definitely get a really good run on a north and south wind, because the pitch of the roof is about like so, and as the air comes from the north and goes over the top of the shed, that wind turbine is right at the peak, and same way with south, grabs a lot of air, and so both are doing really well. Been working on the house and remodeling it, and roof is on the agenda for next year. And after the roof is done, then we are seriously looking at putting in an entire solar system. I'm hoping to get it up on the roof. I'm really debating if I want to go fully up on the roof. It's perfect. It's up out of the way. I may do a ground mount. I'm not exactly sure there, but yes, I am using the solar system, and I'm incorporated a inverter, excuse me, a grid tie inverter. So it basically just pumps it back into the house. Sometimes I go out there and I use the power in the shed, and I have an inverter, a modified sine wave inverter that I use for loads in the garage or the shed. But I don't. I have a grid tie for pumping it back into the house. So, go ahead.
I was going to say that from my background, I'm excuse me, I'm a electronics guy. I'm a industrial controls person, and the fact that I'm always been an off-the-shelf person. You teach in school, buy new, design, whatever. But I've learned a lot from you over the last few years of how to be more efficient. And I'm taking what I know and trying to be more efficient. So I know that at one point you and I worked on that control system for the high wind for your wind turbine. So if the high wind was to come about, the system would go into automatic braking. I know we messed with that for a little bit. That was a fun design to work on. And for those who don't understand how that system works, is if you have any kind of a fan or a propeller, and the wind blows too fast, you can actually destroy the propeller or put too much power into the grid tie. So what Guy proposed and we talked about and worked on a couple years ago now was a system that would sense that and then go into a braking mode in order for it to and that was by basically shorting out all three phases on your controller with a contactor. So, but just simple things. But yeah, my system has always been I've learned from education books, industrial stuff. That's what I've always learned from. So I've definitely been watching your videos. I've been a fan for a long time, and then a good friend of yours, trying to learn how to be more efficient in my own aspect. But just going on some things. John was mentioning also in the comments that he uses 12-volt light bulbs in his house, and that's, if you use a 12-volt system, it means you're charging your solar panels are 12 volts. You're saving 12 volts in a battery system, and then you're transferring the 12 volts into the house using a DC style or DC rated breaker system for like a panel to be able to get into that. That's a whole different genre. I have the whole house on a 12-volt system instead of 24-volt systems. So you're basically off grid, and when you're not producing or not using the sun to produce energy, you're back on the grid, and then you have to transform, with charge and stuff to keep your stuff maintained. But that whole technology is amazing.
Careful, Joe. You're getting into a Edison and Tesla discussion.
Oh yeah.
I love that he's doing that, because that is the most effective way to use sunlight power or photovoltaics is to use it, because you're producing DC and use it DC, so you don't get those inefficiencies. Joe, you talked about like a laptop computer producing all that heat. When you look at that, and I actually have one sitting right here. This that's cords are tangled up, but all them little black boxes, that's what they are. They're big transformers. And they have to take the AC power, which is, and turn into DC so that you can use it. So by using DC power right off the get-go, it's he's way ahead of the curve there and doesn't have any efficiency losses. And so I guess I would implore everybody just to get some solar panels and play around with them, and you can start with a very small solar setup. Go down to your local Harbor Freight store. For under $200, you can buy a solar system and set it up, and you can start playing around with it and making electricity. And I hope you get the solar bug, because I got it. And man, every time I even just look at my solar panels, I'm giddy. I love it. And there's so many devices and things that you can get. Here's one right here. This is equivalent to 1 amp charger. That black box you plug in the wall, this right here will charge your phone just the same as one of those things you plug in the wall. And you could stick this in a window, take it with you and hike and camp. And that's why I have it. Take it with me when I go on overnights or camping or something like that. But there's lots of different things that you can get involved with to help reduce your energy costs and things of that sort. Hey, Joe, it was a pleasure talking with you and doing this live event. And I'm glad you were able to see the comments on your side. So maybe in the future we can respond to more of them earlier. I'll get it started up at the very beginning. But it's great discussion, Joe.
Well, yeah, it's a real pleasure, and I'm hoping you can keep producing videos and produce how-tos and help things, because I learned what I learned from asking, and people out there that been in the fields for years and years. I mean, they've been doing this stuff for 20, 30, 40 years, whatever the industry they were in. And by simply just asking them questions and just being curious. A lot of my stuff is self-taught. I mean, I just trial and error, push a button. Nope, that didn't work. Let's try a different one. And
just don't push the red button.
Yeah, don't push the red button. Don't cut the blue wire. But trying to just to be more knowledgeable to help myself in the long run has helped me go very far. And not that I'm any smarter than anybody else. I just ask questions, and I'm hoping that these videos provide that same mentality, that we can share our knowledge for people that don't know how an inductor works, or how wattage is calculated, or how a light bulb works. And hopefully through our efforts we can at least have reference out there for people, or educate somebody that maybe they were missing that one little part of a project they're working on for years, that they just haven't got to that one part to be more efficient, or to be more off the grid, or be more whatever, have that one thing. So I'm hope people can really keep commenting and give us ideas for our videos.
Joe, that's the nice thing. Okay, so the world is changing. We are communicating through our laptops and streaming this out to as many people that want to come in and join this. This is an awesome era for us to be in right now, and it's a great opportunity and platforms to learn from. This is free information, and all you have to do is tune into it. And when we were kids and young adults, you watched what was on cable or the TV antenna. It started out as a TV antenna when I was a kid, and then we got cable, and it's all of 13 channels, and it's gone up from there. And today you can just go out and seek out the information you want, and we're trying to provide the information that makes everybody more sustainable. And with that being said, I go check out my Facebook page, which is the links in the description below. It's encompassing self-reliance, and the website is encompassingselfreliance.com. And for you HVAC guys or gals, there's encompassinghvac.com as well. We're trying to encompass all of this information, and we're at the beginning stages of our journey here. We are trying to put together a comprehensive content package that will take you into your own self-sustainability state. And with my background and with Joe's background, there's not much that we can't cover together and bring to you guys. And understanding all of these systems. One goal, Joe, that I have is if I can teach or bring the information to somebody that can have, I want to build a process for people so that when they look at something, they can figure it out. And I'm going to just use this as a really simple example. Okay. This is something that I made. Okay, though, let me back up. Joe said he's off the shelf. I figure out how to make stuff out of other stuff all the time. That's what I do. Everything I do is I'm looking at other things and figuring out how to make it. But when you look at something and you want to understand how this works, you have to have a mechanical aptitude and you have to have a process. And we're going to get into troubleshooting in a future video. And we're going to teach you processes that you should implement on everything you do when it doesn't matter what you're looking at or what you're going to try to troubleshoot or what you're trying to figure out. You need to use these systems to figure these things out. And by knowing how things work and what they're supposed to do, then you can figure out how to fix them or how to implement them in another purpose or repurpose things or, things like that. I just kind of rambled on there a little bit, but you get the gist of what I'm trying to say.
Yeah, it's like like you were saying, is sometimes it's better to MacGyver things, use things that are available to you to build things that you need. And sometimes or some days the store's might not be open. Either for you're just in a pinch in a snowstorm, or something's going on, or you can't get to the store. You got to make something. It's good to understand how things work. So
yeah,
actually,
it's all about just being self-reliant. I can rely on myself, and that's it. Just I can rely on myself. And you said something about having that knowledge, Joe. And I have a saying that says I can carry more in my head than I can on my back. So if I've got it in my head that I can make something out of something else, and I can fashion something out of other things, then you've carried it up here, and you don't have to carry it with you on your back. Well, Joe, that's going to pretty much wrap up this show. I think we went, holy smokes, about an hour and 42 minutes. I think we overdid ourselves in this video. But I'll look forward to doing the next one. And everybody that's tuned in, if you've stayed around this long, congratulations. Bravo to you guys. We are still working on a schedule. Joe works a very hectic schedule on third shift. I work a hectic schedule on first shift. So sometimes it's hard to get our schedules to marry together, and we can do these on top of our day-to-day things and produce this regular videos and content and still be a husband and father. It's a lot. So to produce this content is not as easy as you think. There's a lot that goes into this. There's a lot of pre-discussions that we have before we even turn the camera on, and trying to bring everything together and get it out for you guys. So with that being said, we're putting together a Patreon page for this YouTube channel, and I'm going to launch that pretty soon. The link is down below, but I haven't done the official launch yet. But that is available if you guys are interested in supporting us or our goals and getting this information out and getting it available for you in all sorts of different ways. Keep an eye out for our podcast coming up. That's in the works. The websites are still in the works. They've been put together a little bit, but everything's still in the works. You're coming in, excuse me, at the beginning stages of a lot of this. So thanks for tuning in, and we'll see you on the next video. Thanks a lot, and thank you for all your support.